Alright, on this video I want to talk about when we're going to use some of the different rules and laws that we've learned so far in trig. And the first one I want to talk about is so katoa. So when you're writing so katoa, remember that that's going to only apply to right triangles. Just right triangles. Okay, so katoa, sine, cosine, tangent ratios, right triangles only. The law of sines, right? We have, usually we have to be given an angle across from a known side. So we have to have at least that, or we have to be able to get the angle across from a known side. And so the law of sines then, if I have an angle with a side in between and an angle, or I have an angle, two angles, and then a non-included side, these are going to result in one triangle. That's it, one triangle. Okay? If I have the law of cosines, and they give me all three sides, or they give me side with an angle in between and a side, then that's going to always have one triangle. Okay, so all of these instances, if this is the given information that they give me, it's a right triangle, or they give me three pieces of information, this could be on any triangle. The law of sines and cosines could be any triangle, including right triangles, right? But they're always going to result in just one triangle, just basics. In fact, on any of these cases, if you get an error message, you did something wrong. Okay? You're never, ever going to get anything other than one triangle for the law of cosines. The law of cosines will result in one triangle only. That's it. There's no special case, nothing else. Okay, so that means that on most things, we're just going to get one triangle, we're going to solve it, and everybody's going to be happy. In this one particular instance, however, if you are given a side, and an angle, notice that's different from every other one that's listed here. This is the ambiguous case. And there are three possibilities. One possibility is that you just have one triangle, like everything else, right? But another possibility is that there is no triangle. And that's when you get an error on your calculator. Okay? And then in rare cases, but it does happen, you would get two triangles. Two triangles. Okay? And that's where you would have to relate the two angles by 180 degrees, and there's this big process and you have to. But if there's two triangles, aren't there at least one? Isn't there at least one triangle? So even on here, you could still find one triangle, even if you can't find the second one. All right? And the second one is always going to be related. One of the angles, one's going to be acute, the other's obtuse, and they equal 180. Okay, so this is just one more time going back over this, but if you'll notice this, in most cases, you're going to have one triangle, right? One triangle only here, one triangle only here. And in very rare cases, there'll be an error message, and in even rarer cases, there'll be two. And this is only for the law of sines. So this would be the law of sines. The ambiguous case goes with the law of sines. Okay? Okay, here's the actual lesson for today, and it's on the area of triangles. And the first way, we'll just start with the beginning, is the one you're used to, which is 1/2 base times height. So the area of just your basic triangle is 1/2 base times height. And sometimes you write it this way. You take the base times the height and you divide it by 2. Those mean exactly the same thing. This here is the base. And the height of the triangle is always the altitude. This is an acute triangle, so the altitude or the height is inside the triangle. But, you know, if it's in a right triangle, this is the base and this is the height. And if it's obtuse triangle, then this is the base and that's the height. So anyway, that's the easy one. You know how to do that. Okay, so now the second type is called the trig method to do it. And that's when you don't have the base and the height. In fact, what you're actually going to be given then is maybe two of the angles, or two of the sides and another angle. and not the height. So let me show you how we derive it, and then I'll show you how you use it. It's pretty easy. To find h, the height of the triangle, you would say the sine of A is equal to h over b, right? Now look here. This is the right triangle. I can show you. This is the right triangle, right? This is opposite over hypotenuse, so we have this. Okay, so that gives us then, if you solve for h would equal b sine theta. Okay, now how do you find the area of a triangle? Well, the area of a triangle is 1/2 the base, which is c, times the height, which is h. Right? You agree? So then what is h? We're going to do a substitution. The area would be 1/2 c, side c, times h, which is b sine angle A. All right, so let's take a look here. They gave us A, C, and B. That's all we have. So in order to find the area, all I have to do is just take 1/2, the two sides I'm given, and the angle in between, and I've got it. So another way to write this, because I could find it using another way, would be the area is 1/2 AC sine of B. Are you seeing the pattern? And another one would be 1/2 AB sine of C. And all of these can be derived from that. So if you're given an angle and then two sides, but not the height of the triangle, you can use the trig method to find it this way. Okay, so here's an example on the next screen. Okay, take a second to stop the video and copy this triangle down. Notice it's an obtuse triangle, and I'm not given the height of the triangle. And it would be very difficult to find the height of this triangle. So 1/2 base times height doesn't work. But I do have, I have sides, I have a side angle side basic configuration, right? I have an angle and then the sides on either side. So this is just the trig. To find the area, I'm going to take 1/2, 52 times 90, sine of 102. Okay, that's it. So I'm going to do 52 times 90 times sine of 102, divide by 2, and get an answer. And I get 2289, and that would be inches squared, because it is an area. An area is always in inches squared. Okay, so really that's all it is. And so if I have basically side angle side format, then I would use this trig method to find the area of that triangle. Okay, the third type of a method to find the area of a triangle has been around since the ancient Greeks. Heron, or sometimes called Hero, was a Greek that lived about 100 BC. So this has been around for a very, 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 very long time. And this is the method you would use if all they gave you were sides. No angles, no height, no other way to find the area of a triangle, except just all you know is the sides. Okay, so they've had this for a long time. Here's Hero's formula, or Heron's formula, and it looks like this. The area is equal to S times S minus A, S minus B, S minus C, where A, B, and C are the sides of the triangle. Okay? So that's awesome, because I'm looking at the triangle and I'm thinking, where is the S? What is S? Where did they get that? Well, this is S. S is the sides added together and divided by 2. It's not the average. The average would be divided by 3. So this is just add the sides together. There's 3 sides in a triangle, divided by 2, and that gives you an S. So an example would be if they gave me the sides of A is 5, B is 7, and C is 10. And so the first thing you would do then is find S. S would be equal to 5 plus 7 plus 10. 22 divided by 2 is 11. All right, so to find the area equals 11 times 11 minus 5 times 11 minus 7 times 11 minus 10, which is 1. I love that one. And that is going to be equal to 11 times 6 times 4, and that is equal to 16.25. Don't forget your units, squared. All right, so that's how you use Heron's formula. The hardest part about it is just trying to remember the formula. But other than that, not a big deal. So this is what you use then if you're given all three sides. Okay, so on here are your sample problems. This is number 1, this is number 2, and this is number 3. I don't know why it's writing like that. That's kind of cool, though. This is what I want you to do on homework. I want you to work these 3 problems, and you're going to use, each one is a different method. So have that in your notes, ready to go, and I will check that when we get to class.